Hey guys, it's me Mohammed back from another. Hey guys, it's me Mohammed from Onchain Investigations back with another video. Today I wanted to show you this tool I've been building based off of Selvyn Kerkour's Blackhat Rust. This is chapter 10 mainly about building a remote access Trojan, and I've made some modifications to it, and I wanted to show I wanted to show me running it in a quick demo run to show how it works. In chapter 11 and 12, they go heavy into adding encryption, end-to-end encryption, and that's still something that I have on the to-do list. So I just want to show you a quick demo. Got this bad boy up and running. It's a remote access Trojan for educational purposes only. It's not like production ready. This can't be used really. It's a very bloated binary, the agent. So it's got three main directories: the agent, the client, the server. The server is what's going to be running on your machine. It's going to be running on whatever you're using to attack your target, and it's going to be basically the API endpoint that returns information about the agents, the jobs, and the task that it's done, and saves it all to PostgreSDB. And then you have the agent. The agent is what's going to be actually the malware that's injected onto your target computer. So this is going to be hidden, or better be hidden at least, so modern antivirus detection don't find it or whatever. And then the client is where you're also going to be using on hopefully a separate machine where you interact with the server via an API, which should have end-to-end encryption, and so nobody could eavesdrop on it or compromise whatever operation you're running. And then that client that you're running, it'll be a CLI app, command line interface, where you can query, run commands, and once you're inside somebody's infected computer, you'll be able to see their whole directory. So let's go give it a run. Let me open up a terminal here and make sure it's big enough for you guys all to see. One second while I get this ready. Okay, let me open up 3 windows. Let me zoom in on all this stuff so you guys could see. So cd zk-rat. This is the directory that we're going to be in. And then let me go here, zoom in this. Make sure it's big enough so everybody could see what's going on here. And then make sure that's all nice and big for you guys to see. All right, let's go in here and run make build. This is going to build out everything we got. So looks like there's a warning. Yeah, it's a warning from the warp package. I don't know why it's giving me this warning about me having an opaque type. I tried fixing it, but it seems like something I could just ignore for now. If you're a warp expert, I'd love to know if you ever had this issue, telling me to add this type to the generic types right here. And when I do, it's having a build error, so I just ignore it for now. But let's go ahead and run the server now. Let's cd into target. I did a release build. As you can see right here, we have the server, agent, client. And let's just make sure it's still big enough so you guys could see. All right, so I'm in my release. I'm going to run my server. And now my server is running here on localhost 8080. And then I'm going to go into here, cd into target releases, zoom in for you guys. And then I'm going to go ahead and run the agent. And the agent is, I'm basically going to infect my computer with this agent. So the agent is now running. This should ping over here on the server once it's up and running. There you go. You see that? Get API agent. So this is the agent ID in the code right here. I'll show you guys right here. An agent. So we got endpoints right here. So it registers the agent at this server URL is going to be localhost right here, as you can see. And let me zoom this in so you guys can see as well. Server URL. So the endpoint is going to be API/agents. And if I go ahead and query that right here, let's try and do a Postman query to that endpoint. There you go. So what we get. So there we go. We get the agent ID 346, ends in 9BD. Created at timestamp, last seen at timestamp. And that's one of the structs that we have in common right here. Go into common. let's go to agent right there. So that's the struct for agent. It's created at date timestamp UTC last seen at ID, and that's what we've seen right over here. So it keeps pinging back that it's got the endpoint, the agent is running. This is how I'll know on my server that I'm in somewhere. And you see it even tells me I just got a 200 response from Postman runtime from doing that API GET request. So agent's running. Now is the fun part. Let's go into the client and let's have some fun, baby. So let's go into here. I want to make this bigger and give the client more space. This is where we're going to be doing all the action. Yeah, the agent is pretty much just going to stay like that. So now that we're in the client, let's do this. What's going on? Oh yeah, I'm not in there. All right, so there's the client. And here's the client application. So agent, we're going to be able to list agents. So let's try that. There we go, baby. Same agent ID, created at timestamp. I have one agent currently. So let's say you have this rat and it's running and you've infected hundreds of computers. You have a long list of agent IDs running in my Postgres DB up here. And it's all saving all this information in my Postgres. So let's run an execution command. So to run an exec command, you'll pass the -- agent with the flag agent with your agent ID, which is going to be this right here. And then you're going to run a command, baby. So let's run the command, list the directory, and let's see what happens. -- agent. Paste this, and then let's run a command. Let's run a ls-a. Let's go, baby. I just did a LSA inside this target directory, and this is exactly what was right here. If you see libcommon.d server saying all that stuff. Yep, there's our agent still running. And let's try and get the jobs. I did a bunch of jobs, and you see here when you print out jobs, it has a agent ID created as well as, you know, the job ID when the job happened, the commands I ran, LSA. This is what got me when I was inside the this is when I listed all the files inside the target release folder, which is really not important because that's inside the cargo build. But when you want to go into somebody's root directory, you want to go into somebody's user etc directory, user directory, and all the other important directories. So let's figure out how we're going to do that right here. And this is me inside my home directory. So you can see I have documents, dev, a bunch of important stuff I would not want a hacker to get. And then if they went back a little bit, they would get into my max user directory, which is, let me show you. This is what they would get. Somewhere I do not want them to be. So once a hacker is in here, you're pretty much wrecked. And once they have sudo access and are able to escalate privileges and get sudo. So let me show you something I have going on with this as well. So as you see up here, this is my agent running. I don't know if I'm blocking it, but you see right here, this is my agent running right there. And I'm going to try and run a sudo command. Let's see what that does. So it's going to prompt me for my password up here. You see that? Now it wants the agent in the target machine to give the sudo password. So it failed because I'm using an unwrap, which makes it panic. So in production, you wouldn't want to unwrap anything in Rust. You want to always make sure you handle these errors and don't let your application panic. So let me try and put my password in and do that sudo LSA. Yeah, still, now I get it because I put in the password in the agent side. So what else should we do? Yeah, this is my agent ID that's running ZK Rats, and there's some stuff in here I don't want you to see, so let's go get all my jobs again. So as you see, it's the most recent job, and this is here. So yeah, this is a very well-crafted remote access Trojan. It's got my server running. You want this running on a separate personally hosted, not on the cloud, because AWS would take you down. And you want the agent infecting the target computer, and then you want your client, which would be you, speaking to your server right here. And if you want to dive into the code, we can right here. I like to look at the server first. So I have a DB migration going on here. So it's sending all the data that I'm getting, all these jobs that I'm doing to my Postgres SQL database. And then let's go into the API, the routes. So we're getting agents. We're posting agents. What else is here that's important? So creating a job takes in the app state, which uses the arc smart pointer. The arc smart pointer is a smart pointer in Rust that allows safe multi-threaded access to a resource. So we need that in a program like ours because we're doing a lot of thread safe computing, and it's a very important tool to know how to use in Rust. Atomic references counted. There's a bunch of videos going deep dives into interior mutability in Rust, mutexes, arcs, RC, ref cell. Those are some very important Rust concepts you have to know. So we're posting the job results, getting the job results, getting the agent job, and getting all jobs. So for this to actually be used in production or in a real life scenario, you'd want this agent to be very condensed and in a very small binary, because it's in a very big binary right now. It's not condensed, it's not optimized. This agent that you're going to infect somebody with would be the actual binary that's actually going to attack somebody's computer. So thanks you guys for watching. Make sure you hit that like and subscribe button. I'll do more videos if you guys want to do chapter 11 together of the Blackhat Rust book and actually add end-to-end encryption to this. So because we want to speak to the server with our client, we want to make sure everything's encrypted end to end all the way. No, nothing can be leaked, nothing can be hijacked. It has to be us. So we'll use a lot of public key cryptography. We'll use some key derivation functions and a lot of TLS security, so we can make sure this is HTTPS secure, not just HTTP. But thank you guys for watching. I'm gonna upload this video and upload some more. We can do a deep dive into this as well if you guys want to. Make sure you let me know what you guys want to see next. Thank you.